Okay, so we're looking at an extension to the normal distribution. It's called confidence intervals. Okay, so an interval estimate is based on how confident you want to be. So the more confident you want to be, the wider the interval has to be. So for instance, I've got maybe a test with a mean of 70, and I'm trying to find what scores will encompass a 95% confidence. So what scores are needed so that we're 95% as 95% of scores are contained. Okay, so copy that and come across. Okay, so typical confidence intervals are 90, 95 and 99. There are other ones, but they're the typical ones. So what happens is, for instance, if you're in a maths test and I want to be 99% confident where people are, if you fall outside that level, then you could say that you're not in the 99% confidence. That means you're so not an abnormal result, but you're an exceptional result. To find the confidence interval, we need to find the z-scores, and I'll do that on the next slide, that align with that confidence interval. And what we do is we use the areas going backwards. Okay, so we're going to calculate z-scores. So copy that and come across. So for instance, here's my first example. If I want to be 90% confident of scores, where the scores are, that means I have 5% on each end. Okay, so 5% on each end makes up my 100%. So the area behind would be 95%, or the area behind is 5%. But we'll just do the positive one and use the symmetry of the shape. So what we're looking for is where in the table is approximately 0.95. So you just scan through and you end up in this little block here. Okay, so 9495, 9505, halfway in between is 9500. So we can say that the z-score is 1.645. Okay, 1.645. And with the symmetry of the shape, the other z-score at the other end will be minus 1.645. So once you work out one, you've got the other one straight away. Okay, so that's the first one. So I've started these other two, so 95% and 99%. So 95% would be 5% lost, which would be 2.5 on each end, which means that you're looking for 0.975 area. So what I want you to do, and then I want you to do the next one, I want you to scan through the table and see if you can find the z-scores that equivalent to 0.975 and to 0.995. So pause it, and when you're ready, come back. Okay, so for 0.975, okay, there's 975 just there. So it's 1.96, so it's going to be plus or minus 1.96. And for the 995, the 995 is between those two numbers, so it's 2.575 plus or minus 2.575. Okay, so those are the z-scores that you could put in your cheat sheet because they're always going to apply. So for 90%, you've got plus or minus 1.645, plus or minus 1.96 for 95, and plus or minus 2.575 for 99%. Okay, so copy that and we'll look at some examples. Okay, so in my first example, I've actually changed it, so I've got an 80% just to make it a little bit different. So I've got 80%, which means I've got 10% at each end. So looking in the table, we're looking for a 0.9. So closest number to 0.9. Okay, the closest number is that one. So it's 1.28 is the closest number. Okay, gone by too far. So Z will be plus or minus 1.28. Let's make sure I've got the right number. 1.28. Okay. So what's the 80% confidence interval for the standard variable Z? The answer is Z equals plus or minus 1.28. Okay, so that's the first one. So you can copy that down and come across when you're ready. We'll do the second example together. Okay, so we're looking at now an example where this time not only do we have to find the z-scores, we then have to find the interval given the scores. So 95%, we can just go straight to our 95%. So we've got plus or minus 1.96. So Z equals plus or minus 1.96. So how you work it is this. So the interval will be the mean, 54, plus or minus 1.96 times the standard deviation, 12. Okay, so get my calculator out. So 54 plus or minus 1.96 times 12, so 23.5. I won't worry about all decimal places. So my upper number, my lower, that's not right, I've done something wrong there, clear. So I'm going to go 54 minus 23.5. So my lower number, my interval is 30.5 up to 77.5. So with that interval, I have 95% of my scores. Okay, so if you fall outside that range, then you are in the top 2.5 or the bottom 2.5, and that's exceptional. Okay, copy that and come across. Okay, so there's an exercise on Moodle that you can do for one of the textbooks I'm using. Okay, and that's it.